Happy November! This video for IB Physics on topic 6 is only about solving problems where you have magnetic forces and their fields, some electrical currents, and maybe even some moving particles within those magnetic fields. Get ready! Here's a couple problems about magnetic forces. Why don't you pause it and see if you can solve the first one. Now after that, you saw hopefully that it was asking for force that gave you a magnetic field strength, a length, and a current. So you should know to use one of my favorite equations, Philb. And so the current is your 8 amps. Your length of the wire within the magnetic field is this 10 centimeters. But you need it in meters. So we're going to convert that to 0.10 meters. B for magnetic field, as I like to call it, is the 0.25 T for Tesla. And the angle between the wire and the field is 90 degrees, because they say it's perpendicular to the field. And then you work this out, you are going to get 0.02 newtons. And the sine of 90 degrees is 1. And which is good, because that means this is the largest value that you can have, because you get maximum force when a wire is perpendicular to your field. So that is your answer. Now pause it and try the second one. It's based on the first one. We're still going to use Philb. And what's nice is that we have all the exact same values for current, length, and magnetic field. So that still gives us 0.02 newtons. However, our angle is now 30 degrees. So we're going to take sine of 30 degrees. And you should be thinking, whenever you have an angle that's not perpendicular to your magnetic field, you're going to have a lesser value of force than you would otherwise. And so that's why you get the 0.02 newtons times 0.5. And that cuts it in half to give you 0.01 newtons. Here's one of the IB's favorite things to do, is give you a magnetic field problem and combine it with circular motion, which is actually kind of cool to show what you know about magnetism and circular stuff, and makes you feel good about yourself if you get it right. So take a minute, pause this, and see what you can do with it. For something that's going to be going in circular motion, we can say that Newton's second law applies. Now our force is going to be the magnetic force on a charged particle. So that is going to be QVB sine theta. And the acceleration of something in circular motion, I'm going to put it in here as V squared over R. And what's nice is that this is always going to be moving perpendicular to the field. So we can say that sine of 90 degrees will be 1. And we're going to have one velocity cancel out. So we still have a velocity here. And I want you to solve for that speed. So if you rearrange for this, we're going to have QB, this R comes up here, and we're divided by the mass. Then it's just a matter of plugging in your numbers. It's an electron, so we've got the elementary charge from your data booklet, this many coulombs, the magnetic field strength. Now remember, this is micro teslas, so that's 200 times 10 to the negative 6 teslas. The radius has to be in meters. There's lots of things you got to do just right, otherwise you're going to get not quite a satisfactory answer. And by that I mean wrong. And the mass is the mass of an electron. Everyone in the US knows it's 9.11 times 10 to the negative 31st kilograms. And then you solve for your velocity. You're going to end up with 7.0 times 10 to the 6th meters per second. And that's a giant number, but you want to be reassured by that because it's an electron. And electrons are always going to be moving crazy, crazy fast.